In this video I'm going to be looking at the solution to question 4 of the June 2010 Edexcel D1 paper, and the topic of the question is route inspection. The question refers first of all to a figure 2 which models a network of tunnels that have to be inspected, and says the number on each arc represents the length in kilometers of the tunnel. Malcolm needs to travel through each tunnel at least once and wishes to minimize the length of his inspection route. He must start and finish at A. So we're asked to use the route inspection algorithm to find the tunnels that we need to be traversed twice, and we should make the method clear. In the second part of the question, we're asked to find a route of minimum length starting and finishing at A and state the length of the route. So once we've done that, it says that we're going to have a new tunnel built from 2 points from C through to G, which will be 10 kilometers long. And says Malcolm will have to include the new tunnel in his inspection route. So what effect will that have on the total length of his route? And we should then justify your answer. So taking these one at a time then, so this is a classic sort of route inspection problem. So the first part of the procedure is always to identify the odd nodes. So looking at those, the odd nodes are B, E, C and G. So odd nodes, and we should just write down what they are. Odd nodes are B, C, E and G. So pairing those, then they can be paired together firstly as B, C, E, G, or alternatively as B, E and C, G, and finally B, G and C, E. So three possible different pairings. Now it's worth noting, I think, that from B to C we have different routes that we can go along. There's a point A which is just not come out there on the diagram properly, but point A is at that point on the diagram there, and you can see that the route we need to go is not directly from B to C, but it's from B to A to C. So I'll just put in brackets here that this is from B to A to C, because that could be important later on. And there's a total there of 10.4, and from E to G it's 10.1. So this gives us, added together, gives us a value for that pairing of 20.5 kilometers. Doing a similar thing for the others, BE 8.3, CG is in fact C to D to G, which is 16.1, and adding those together gives us a value of 24.4. And finally BG, which is actually B to D to G, and then CE, C to D to E. These are of length 14.9 and 11.9, giving a total of 26.8. So the ones that we need to traverse twice are given by this first pairing. So this is the minimum here. So the minimum is 20.5 kilometers. So we should traverse from B to A, and then from A to C, and also from E to G twice. So those three routes. So be careful that you do have the three routes and you don't just say from B to C, because that would be ambiguous. Do we go from B to A to C or B to D to C? So you must make sure that you have all three routes there. And then it says find in part B, find a minimum route starting and finishing at A and state the length of the route. Well, there are many alternatives to the actual minimum route. So, but one thing to check is the number of arcs you should have to repeat. So if you count up the number of arcs on here, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we're going to have 3 repeated. So in total we've got 13 arcs. So just as a hint, if you've got 13 arcs, that must mean there are 14 nodes that we're going to have to write down, starting at A and finishing at A. Now one particular set would be A, C, F, G, E, G, D, E, B, and then D, C, A, and finally B to A. So I say there are many different routes, but do check that you've got 14 nodes in your route. However, the one thing that which won't be different from everybody's answer is the total length, and the length will be the length that we're given in the diagram, which is 73.3, plus the extra length that we're adding on, the total of 20.5, so giving there 93.8 kilometers. Looking at the marking for those two parts of the question, in part A there was a method mark and then A marks for each of these different pairings, and then identifying the minimum, there was then an answer mark once you'd stated those that we needed to complete. So 5 marks in that part of the question. In part B of the question, 3 marks, a B1 mark for getting a route, and then M1 and A1 for getting the value 93.8. The question goes on and says that we're going to have a new route or a new tunnel built between C and C and G. So if we put a new tunnel in here, what's happened now is that we've changed those odd nodes into even nodes. So C and G are now even, and therefore we only need to repeat from E to B. So if you imagine that what we're doing now is just putting in this extra one here, and then we've now got in effect all even. So we can start at A and finish at A following that route. Well, CG we're told is of length 10 kilometers, so that the new length will be the total 73.3 for those marked on the network, plus the 10 that we've added in for our new one, and then plus just 8.3 this time for repeating from E to B, and that gives a total of 91.6 kilometers. So therefore we can say that the route length has decreased. Marking this time just the 2 marks, and there were 2 B marks given for saying, well, we've now only got the even node, sorry, I beg your pardon, for saying that C and G are now even, and therefore that the length was decreased with some justification. and the most likely one for that is to actually calculate the new length and say that it has gone down. So just the 2 marks there. Well, that concludes the solution to that question. You can find solutions to other questions at www.furthermaths.org.uk.